Okay, let's do a couple problems to review graphing rational functions. I hope that you remember what the parent function of a rational function looks like. How's that? Does that look familiar? Okay, so what's the transformation that takes place here? Very good. I moved left 2. So in the blue, I'm going to graph the actual function. And just to try to save time today, we are not going to do the directions. The directions say list the domain, the range, the horizontal, vertical asymptotes. We're not going to do that right now because we did it before. I know that you would be able to do that if we talked about it. It's the vertical line that the graph approaches but never touches. Okay. So the blue is what the function actually looks like. So we spent time graphing these. You guys did an excellent job with them. Negative 2 over x minus 3 quantity squared. Now, what does this squared on the bottom do? Yeah, they're both above the x-axis then. But then there's a negative. What will that do? They're both in the bottom. What does the x minus 3 do? Right, 3. Very good. Good job. How about the next one? Up 3. Very good. Vertical asymptote still at 0. There we go. Let's go to this one right here. We got a lot of things happening there. Negative 4 over x minus 2 quantity squared plus 1. Okay, right 2. Up 1. Okay, very good. Natalie says that the squared will make them both be above the x-axis. But then because of the negative, they're both going to be flipped below. So our graph will look like this. And so we're actually able to sketch these graphs pretty quickly. These reciprocal functions are quite interesting. This one right here? Yeah, exactly. If it's an odd degree, then it's going to be in opposite quadrants. Yep. Good? Okay, flip it over. So that was easy peasy. Let's look at something that's not easy. What's different about this type of problem? There are multiple x's. Oh my goodness. What do we do? Let's start by identifying something that will help us sketch the graph a little bit easier. Let's consider the x-intercept and the y-intercept. Or intercepts if it happens to be. Who can tell me, how do I find the y-intercept? The y-intercept happens when x is 0. So if you plug in 0 for x, what do you get? 0 over 3, which is 0. Everybody okay that if you plug in 0 for x, you have an output of 0. Okay, then if I'd like to find the x-intercept, I set y equal to 0. And I come up with this equation. 0 equals x over x plus 3. Oh boy, that's a good question. When is x over x plus 3 equal to 0? Well, if the denominator is equal to 0, is the entire thing equal to 0? No, if the denominator is 0, then it's undefined, right? If the denominator is 0, it's undefined. If the numerator is 0, then it's 0, right? So when is the numerator equal to 0? At x equals 0. So when you want to find the x-intercept, just look at where the numerator is equal to 0. When you want to figure out the y-intercept, plug in 0 for x. Now, I know we've talked about the 0 in the denominator, undefined, 0 in the numerator, 0. That works for every situation except if you end up with 0 over 0. 0 over 0, we don't know. Infinity over infinity, we don't know. That's actually what calculus means, the implicated idea. It is not one, no. Okay, so there we go. Let's figure out how to do the rest of it. And it says that we have x divided by x plus 3, so let's just divide it. What do you multiply x by to get x? 1. So therefore, it would be 1 minus 3 over x plus 3. Isn't that the same as negative 3 over x plus 3 plus 1? Don't we know how to graph that? So all I've done is taken this and rewritten it so that I can graph it. This is shifted how many up? 1 unit up. Shifted left or right? Left, how many? 3. And it's a vertical flip, right? And notice it says it goes through 0 for the x-axis and 0 for the y-axis. So I know it goes through that point. There's my graph. Now for today's assignment, you're going to need to list the x-intercept, the y-intercept, the horizontal asymptote. The horizontal asymptote is the line that the graph approaches but never touches. And what is that? Y equals 1. And the vertical asymptote, x equals negative 3. Very good. What do you think? We okay there? All right, let's try to roll through a couple more before we get to the complicated ones. X-intercept, y-intercept, horizontal asymptote, vertical asymptote. I want to find the y-intercept. What do I plug in? 0 for what? X. And what do you get if you plug in 0 for x? 4 over, which is? Sweet. Y-intercept of negative 4. Is everybody okay with how I did that? Now remember, because of the logic we talked about, if we want to find the x-intercept, do we talk about where the top is equal to 0 or the bottom? Top. When's the top equal to 0? 4. That was quick. Now let's divide. X minus 1 goes into negative x plus 4. What do you multiply x by to get negative x? Negative 1. You get negative x plus 1. Subtract. What do we get? Positive 3. So therefore I have negative 1 plus 3 over x minus 1, which is the same as 3 over x minus 1 minus 1. Down 1, thank you. Right 1. Pass through positive 4 on the x-axis, negative 4 on the y-axis, as a horizontal asymptote of y equals negative 1, a vertical asymptote of x equals positive 1, and the graph looks like this. What do you think about that? I apologize when I made this one. This shouldn't be a 6, this should be a 5. And I'm doubly sorry, it should be a -5. I swore I changed that before I made the notes. I remember even hitting the keys on the keyboard, but something must have happened. Oh well. Christmas break, we got 4 weeks. 4 weeks, and then you got Christmas break. They're all full, yes. Okay, let's get started. A little bit more complicated. What makes this one different? Okay, it's an x squared on top, and we can factor the top. Let's first look at the x-intercept, and let's look at the y-intercept. Let's do the y-intercept first. The y-intercept happens when? When x is 0, what do you get? Very good, -5/2. Right, we get -5 in the numerator, we get 2 in the denominator. Everybody okay with that? If x is 0, then I get that, okay? Now, if we want to look at the x-intercepts, we have to think about where the top is equal to 0. Does the top factor to x minus 4, I'm sorry, x minus 5 and x plus 1? So where is the top equal to 0? Yeah, so it's going to have 2 spots where it crosses the x-axis at 5 and -1. Now, if I want to figure out how to graph this thing, I got to divide it. I'm going to take x minus 2, thank you, x plus 2, and divide that into x squared minus 4x minus 5. What do you multiply x by to get x squared? X. Okay, x squared plus 2x. Subtract. -4x minus 2x. -6x. Okay, drop the 5 or the -5. What do you multiply x by to get -6x? -6. And I get -6x minus 12. -5 minus -12. +7. So therefore we have x minus 6 plus, whoop, smartboard got stupid. Come on. Very good. Okay, x minus 6 plus 7 over x plus 2. Or I could write that as 7 over x plus 2 plus x minus 6. Okay, so before, you're pretty good. You're like, that's all stuff that I've seen before, but what about this now? Because instead of just a number on the end, I got this x minus 6. Natalie sees it. Now, watch. Okay, this is how I try to think about it. But if I were to continue to draw this graph all the way out here, what would this graph look like as I draw it out here? Just basically a line, right? If I would draw this graph all the way over here, it'd still look like a line, right? It would basically look like a line that passes through 1, right? That's basically what it looks like. It's just that at -3, it blows up. Now, look at this one. If I were to head off to the left, if I were to head off to the right, it would continually have a height right about -1, right? It wants to look like that. It's just that at 1, it blows up. So this wants to look like x minus 6. So instead of a horizontal asymptote, it has what we call a slant asymptote. I just graphed x minus 6. Where does it blow up? at -2. So you can see it has a slant asymptote of x minus 6. It has a vertical asymptote of x equals -2. Well, we can plot some points here. I got x-intercepts of 5, -1, and a y-intercept of -5/2, or -2.5. Looks like it does this, huh? And the question is, what about over here? If I drew some of the graph over here, would it be a function anymore? No. If I drew it here, could it be a function? Yeah, but does it cross the x-axis? Over here? No. So therefore, it has to go down in this region. And that's the graph. Looks crazy, huh? There is no horizontal asymptote. There's a slant asymptote. The slant asymptote is x minus 6. What's that? Yes. Yep. All right. 2 more. This one's quick. What do you notice about this one? Look at the function. See if you can notice it. Factor out a 2. Yeah. So x minus 2 over 2 times x minus 2. And what happens? And you're left with, right, so you get y equals 1/2. But something crazy happens at 2. And we just divided off x minus 2. Something must happen there, right? Because if you would plug in 2, you get 0 in the denominator. Something must happen there. Well, here's what happens. When something divides off, it looks, that's what it looks like. Except it doesn't have a value at 2. Because it doesn't. Look at your original function. If you plugged in 2, you get 0 over 0, right? You can't do that. Now, you may not believe me. I'll show you. If I do parentheses x minus 2 divided by parentheses 2x minus 4, and I zoom as a decimal, see if I zoom standard, it's just going to show y equals 1/2, because it doesn't show. If I can't go right over to 2. But if I zoom as a decimal, then it's going to show exactly at 2. There it is. It's got a gap. There's a gap at 2 1/2. So on today's assignment, if there's a gap that happens, you want to be able to say where that gap happens. If there's something that divides off, you're going to get a gap there. You're going to get a hole there. That's what's going to happen. So let's put it all together. One final example. Does something factor out? What factors out? So what divides off? So since it divides off, there's going to be a gap at what? No. Look at here. The gap happened at 2 because x minus 2 divided off. So there's going to be a gap at 0. Now, I'll show you how to come up with the y value. you would plug 0 into what remains. What's 0 plus 1? 0 minus 1. So divide those, you get negative 1. So that's where the gap's going to happen. So 0, negative 1, I have a gap. So for the rest of the time, we can focus on y equals x plus 1 over x minus 1. We just have to know that there's a gap there. I put in 0 to the top. It says we knew the gap happened at 0, right? We do 0 plus 1, 0 minus 1. We just plug it in. You get 1 over negative 1, which is negative 1. Okay, so now I've got this. Let's talk about some of these pieces. Let's talk about the y-intercept. Where would the y-intercept happen? How do I figure that out? I plug in 0, and I get that. There's no y-intercept, is there? Okay, there's a gap right there, so none. The x-intercept happens when which is at negative 1. So it crosses, so we got a gap at 0, negative 1. We've got an x-intercept at negative 1. Let's figure out the asymptotes. In order to do that, we got to divide this guy, okay? X minus 1 goes into x plus 1. What do you multiply x by to get x? Okay, we get x minus 1, subtract, and we get, 2. So what do we have? Otherwise written as 2 over x minus 1 plus 1. So what's the horizontal shift? Yep, we're going to go over 1, and we're going to go up 1. So it says y-intercept and x-intercept. We have horizontal asymptote and vertical asymptotes. Our horizontal asymptote is y equals 1. Our vertical asymptote is x equals 1. We have a gap that exists at 0, negative 1. And that's what the graph looks like. I'm going to check this. I never get tired of this. I think it's so cool. And I press graph. Hey, I don't see the gap. Why not? Because it's on the axis. How do I get rid of the axis? This is one place where you can allow your math nerdiness to show forth. You have to admit, that's at least a little cool, isn't it? I mean, that we were able to sketch that, come up with that exact thing. There's a gap sitting right there. I think that's awesome. Worksheet for an assignment.